In today's note, we are going to look at exploring transformations of quadratic functions. Basically, what we're going to be doing in simpler terms is looking at how certain values affect the shape of a quadratic graph or a parabola. So, transformations are basically just operations performed on functions or equations to change the shape or position of the associated curves or lines. Specifically, what we're going to be looking at is a quadratic, so that parabola. So how do these certain values change the parabola that we're looking at? Congruent, it basically means identical shape. So congruent means we're not changing the shape of it, we're just changing the position. Similar means there's a stretch or compression of the original figure. So if you have something and say you double the size, you could say that it's similar. It's not identical because it's not the same, but it's similar. So if we're stretching it or compressing it or basically changing the general shape of it, then that's something where we would say that the transformations are similar or the functions are similar. So the types of transformations we're going to be looking at, or at least the terms that we're going to be trying to use, are reflection. So basically reflection means kind of flipping. Vertical translation or vertical shift means going up or down. So are we moving the object up on the grid, down on the grid? Horizontal translation means shifting it left or right. So are we moving our object or our parabola left or right on the grid? Rotation means kind of rotating it. We're not going to be covering that too much in this one, if at all. Vertical stretch or compression basically means are we basically kind of, if we have a graph looking like this, so we're stretching it vertically, you could think of kind of we're pulling it tight, we're pulling it to make it really skinny. Compression would be kind of like we're pushing it down, we're pushing our parabola down, so we're making it kind of wider. And then horizontal stretch or compression, again, same thing, except we're pulling from the sides. But the main ones we're going to be looking at, I'll highlight that you should be trying to refer to reflection, vertical translation, horizontal translation, and a vertical stretch. Those are kind of the four main things that we should be looking at in this investigation. So what we're going to be doing in this investigation is you're going to be using Desmos to understand how three specific values, a, h, and k, in the function or the equation f of x equals a x minus h squared plus k, transform the graph of f of x equals x squared. Now this is basically just a fancy way of saying y equals a x minus h squared plus k and y equals x squared. So we've seen y equals x squared before. This is going to be our base equation or base function. Right? This is our general parabola. So this is kind of what we're going to be looking at. This is not what we're looking at. This is going to be our reference to seeing how the transformations affect this general shape. So as we get into it, again, like I said, we're going to be using Desmos. So if you're not familiar with Desmos, please log into it or go to desmos.com and just basically open up a graphing calculator. I have a video or an image up here that's popped up now. So that is basically what we're going to be using. And I'll have this open here and just kind of walk you through the first one. Then I'll pause a bit and then kind of walk you and then bring up the answers so that you can see kind of what you should be looking at. But again, as long as you enter everything in correctly, you should have no problem. If you're not comfortable using kind of the quick functions to kind of get the certain parts of the equation, you can always use the keyboard that pops up here, and everything's kind of very straightforward. So basically all we're going to be doing is graphing the functions. Again, we see f of x, you can write same thing, y equals x squared. So instead of f of x, you can basically write y, and it's the same thing. You're kind of just getting a crash course on some grade 11 math right there as well. But you can write y equals x squared, So if we do that, y equals x squared, we see now that we have our parabola. And if we click on it, we can kind of see some key points. But basically, we have the general shape. The value of k, well, if this is our general form up here, y equals x squared plus k, the k value is 0 because if I look at the equation, I don't see anything added on at the end, so that means it has to be a plus 0. Direction of the opening, well, it's opening up. We can see in our graph, we can see kind of the arrow, we can see the direction of the opening at the top here, it's opening up. What transformation occurred? None, because y equals x squared is our base function. So there's not going to be any transformation in this. And then if we want to sketch it, just kind of a rough sketch. So we can see that the vertex is right at the axis. Not the axis, the origin. Next thing you're going to do, I'm going to leave the red one up here just to kind of see the changes as we go. So y equals x squared, but now we're going to plus 2. Now we can see what's happening with our blue graph. We can see that again, we've added 2. The direction of the opening is still up. What transformation occurred? Now you can write this in many different ways. You could say vertical translation of up 2, or you could just say shift up 2. Anything along that idea is roughly is good, as long as you can see again the rough idea that on our graph our parabola has now shifted up 2 spots, right? And then this is a case where they are congruent. We haven't changed the shape of our graph. We've only shifted or moved its position. So if we do the next one, I'll do one more. Y equals x squared plus 4. So now the green one, our k value is 4. That's the value that we're adding on at the end. You can see that it's opening up. And again, the transformation, well, how did it change from that blue graph? In this case, it's gone up. So shifted up 4. And if I'm just sketching it, and now it's going to be higher. Actually, I'll just continue and go through this full example of this one so you get a general idea of what to do. Next one, y equals x squared. Now we're doing minus 1. Let me move my graph a bit. Here we can see in purple that now our graph has shifted down. So what's our k value? Well, again, the k value is the number that we're adding to the x squared. So in this case, it's minus 1. The direction of the opening is still up. And here we have a vertical translation of down 1. And if we want to sketch it, there's our axis. It's still opening up, but we're below the axis now, right? Our vertex is below the axis, still on the y-axis. So we're still on this y-axis, but we're below it now. And our next graph, so again, just doing the same thing, entering a new equation, y equals x squared minus 3. I think you might be able to guess what's going to happen now. There we see in black, we can see our new graph. So filling out the chart, our k value is minus 3. The direction of the opening is still up. What transformation occurred? Well, here we shift down 3 units, or basically this vertex has been shifted down 3. And if we look at all the other points, if we were to graph all the other points, we would see all the other points also shifted down 3. And again, if we want to sketch it, doesn't need to be perfect, you don't even need to include numbers, but as long as you get the general idea that we've shifted down 3. So it should be lower than the one we just had. And again, you can use Desmos for this. You can plot them all at once. You can hide the other ones, but I would at least keep that base form, that very first one, y equals x squared, because that's the one that we're looking for, or we're using as a reference for the transformations. So again, how do these two change, or how does the black one change from the red one? Well, we've shifted down 3 units. So that's again what we're referring to. I'm just going to go and hide that Desmos. So what we want to do now is use the table from number 1, or from part 1, to answer the following. What transformation does the value of k do to the graph of the standard function f at x equals x, or again y equals x squared? So what transformation did we see in all those examples? Well, the transformation that we saw was a vertical translation. So a vertical translation, up or down, or basically we saw our graph shift up or down. Again, same idea. One's just a little bit more technical in its wording, but basically we saw the k value shift our graph up or down. So B, what happens to the graph f at x equals x squared in order to graph g of x equals x squared plus 9? So basically, what change is happening? And again, we see f at x, we see g at x. Just replace it with y if that's easier. So you could just basically, oops, wrong one. Basically just get rid of all this and just put y if that's more comfortable for you, or as long as you're fine understanding that all it means is just basically just different terminology for the same thing. So how does the graph change? Well, because we said that the k value shifts our graph up or down depending on the sign. If it's plus or minus, that depends. Here we see a plus 9, so this should be a shift up of 9 units. So basically all of our points have to shift up 9 units. C, again, what happens to the graph f at x, x squared, in order to graph x squared minus 5? Same idea. We know that that k value, or that plus or minus onto the x squared, is going to shift it up or down. Because it's a minus 5, that means it shifts down 5 units. D, what happens to the x-coordinates of all the points on our base graph when the k value is changed? What happens to the y-coordinates? So I'm going to pop up our Desmos again, and if I look at all of the points, I bring them all up here. If I look at what's happening, does anything happen to the x values? And if you look at all these graphs, you should see that nothing happens to the x values. We haven't moved it off of this center line, or off of this y-axis. So for our x-coordinates, nothing changes. But for our y-coordinates, or the y values of all these points, what does the k value do? Well, the y values change by, we could say, k units. So if it's plus k, then we go up, or you add k units to our y values, or if it's negative, we minus. Basically, all we're saying is the k value the k value affects the y coordinate. And basically that's where we get the shifting up or down. So let me go and hide our graph again, our Desmos. And what we're going to do now is, again, moving on now to the h value. So this is h value when we have it in brackets. So we're going to look basically at all of these piecewise, kind of put it together, and in the next lesson we're going to look at it all together, the full form. But this investigation is just going to look at each piece individually so you understand what each part does. I'm going to pause the video to give you a chance to open up Desmos, go through, fill out these tables, to try to do this investigation on your own so you get a little bit more practice with it. You feel a little bit more, or you're a little bit more active in the learning rather than just copying down what you're hearing. But I'll pause the video, or I suggest you do the same thing, and then we will come back with all the answers and we'll go into the summary. So hopefully you've tried this on your own, but if not and you're just copying it down, that's fine as well. So part 2 looks at the h value. These are the answers that you should have, looking at it on Desmos, plugging in the points, and basically this is what you should have seen. One key thing with this, because the h value in the equation, it's already y equals x minus h squared. That means that if we see a minus in the equation, the actual value of h is going to be positive. And the reason for that is because the equation, or the base form, is already negative. So if I had put x equals, or y equals x minus positive 2 squared, I can take out that plus and minus and just basically keep it as minus. If I had, say, we move down to the third example, y equals x minus negative 2 squared, that minus a negative is basically the same thing as saying x plus 2. So that's why when we might see something in the equation, but it's a little bit different from what the actual h value is. So just keep that in mind. If you see a negative in the bracket, it actually is positive. If you see a positive, it's actually negative. So that's just one thing to note. But what we should have seen is that the h value actually affects the horizontal translation. So basically it affects the shift left or right. So if we had a base graph of y equals x squared and we wanted to change it to y equals x plus 6 squared, what happens? Well, we shift left 6 units. For C, what happens if we want to take x squared and change it to x minus 1 squared? Well, here we shift it right 1 unit. We're in the positive direction because h is, in this case, is positive. What happens to the x coordinates of all the points, and what happens to the y coordinates? Well, the x values all change by h values, or h units. And nothing happens to the y coordinates because here we're only shifting left or right. So kind of the opposite of the horizontal or the vertical translation. Moving on to the third part, or looking at the a value. So this is that leading coefficient. We've already talked in previous lessons that this coefficient tells us the direction of the opening, but does it tell us anything else? So we have our first base graph, x squared. Again, same answers as before. But what we should have seen is that when the a value, here we have 2, we should have seen our graph appear skinnier, or what basically we call a vertical stretch. If you imagine holding it at the top and the bottom and pulling it, you're making it taller and thinner. So that's a vertical stretch. If you want to get technical, you could say a vertical stretch by a factor of 2, because that's what our a value is. What we should have seen when the a value was a decimal, or something between 0 and 1, we should have seen that the a value, or sorry, our quadratic, or our parabola, actually got wider. So basically what happens is we have a vertical compression. Basically that's what we call it. Basically our graph gets wider. And for the last two, when we added a negative onto that a value, or made that a value negative, we should have seen our graph flip, or basically it caused a reflection in the x-axis. Basically it's flipping over the x-axis. So that negative actually means that it opens down, which we had talked about in the previous lesson. So what happens, or what transformation does the value of a do to the graph when it's between 0 and 1, or basically a decimal? It causes a vertical compression, or basically it gets wider. B, what happens when it's greater than 1? We see a vertical stretch, or it gets thinner. What happens when a is negative? We get a reflection, or basically we flip it. What happens to the x-coordinates of all the points when the a value is changed, and what happens to the y-coordinates? Well, nothing happens to the x-coordinates, but the y-coordinates, the y values are multiplied by a. So that's where we get that stretch. And technically it's a vertical stretch, so we're only stretching it vertically. So that's why we get that the y-coordinates are all multiplied by a. But the main thing is, as long as you understand what transformation is taking place, that's the key idea that we're trying to get through. So, as a summary, quadratic functions can be written in the form, let me just change this to something we're a little bit more comfortable with, just at least for the summary. Y equals ax minus h squared plus k. And for each of the constants a, h, and k, it changes the position and or the shape of our base graph f at x equals x squared, or basically y equals x squared. So changing the values of h and k changes the position of the parabola, right? It's only shifting it up or down, left or right. It's only changing the position where it's located on our graph. The new parabola is congruent. So basically it's the same shape, it's just in a different location of that base graph f at x, or y equals x squared. H causes a horizontal shift, H for horizontal, K causes a vertical shift. Changing the a value can change the shape of the parabola, right, thinner or wider, as well as the direction in which the parabola opens. The new parabola is not congruent to the parabola f at x equals x squared, or that base function, when a does not equal 1 or negative 1. Right? When a equals 1, that's kind of our base form. Right? If we look at y equals x squared, we can say the a value here is 1. So our base form has an a value of 1 already. So if it's something other than 1, then that means it's not congruent. So state the equation of the parabola for each of the following transformations and graph them. So here you can use Desmos to graph them. It's more for just confirmation. But the parabola moves up 3 units. So when it moves up 3 units, we're referring to the k value. So here it'd be y equals x squared plus 3. Opens down is the a value, and moves 5 units left, which is the h value. So y equals, opens down, it doesn't say stretch or compress, so we're assuming it's just opening down. So we're going to say negative 1 x, and then because the h value, moving left. So left is in the negative direction, so that means in my equation I should see a positive, or if I just want to write it out fully, y equals x minus negative 5 all squared, but I can simplify that to just x equals plus 5 squared. And lastly, the parabola moves 1 unit down and the y-coordinates are being multiplied by a factor of 3. So moving down is the k value, and the y-coordinates are being multiplied by a factor of 3. We could also say vertical stretch. by a factor of 3, which means the a value. So in this case, y equals our a value, told is 3. We don't have an h value, so I can just write x squared, and then moving down means minus 1. So that is our form there. So again, the main idea from this lesson or investigation is just understanding how the a, h, and k value affect the shape of our general quadratic or our base quadratic or parabola y equals x squared. So again, make sure if you didn't go through this, go back, kind of just plug these into Desmos so you can see them all at once just to get a general idea of how these values affect the base function.